Hello, this is episode 5 of How Hardy is made, and we will see the Hardy DynamicFluid4 liquid system. This unique system is extremely fast at reaching the desired application rate. It consists of 4 major components and clever software. The software will be a challenge to show, but I'll get to that later. The main hardware components are the regulation valve and a valve opening meter, the flow meter, a pump revolutions meter, and a digital pressure sensor. Let's start with the regulation valve. This is the biggest component, and assembly starts by placing the valve body on a jig, where a ceramic, metallic or synthetic faceplate is mounted at the base. The lower bearing ring for the spindle is heated, so it easily slides into place. It is firmly seated and lubricated with synthetic grease. O-rings along with bearing house and upper bearing ring are fitted. The guide and plate are assembled, and the screws are torqued to 4 Nm. With thread locking paste, the other faceplate is secured to the spindle. Now the spindle is fitted into the valve body. The base plate is fitted and the motor gearbox secured along with the encoder on the spindle. This electronic component measures the angle and thereby the opening of the valve. The valve is now ready for calibration. Power consumption and the exact point of opening is determined. A light source is placed inside the closed valve. The opening point is determined by an optic sensor. The valve and data are registered, cover added, and the valve is now complete. The next component is the flow meter. It is finished once we have attached the mounting brackets. The third component is the pump revolutions meter, which is fitted to the pump. A metal rotor is attached to the pump shaft, and an inductive transducer on the red front plate. 1 revolution generates 4 pulses. The fourth sensor is the digital pressure sensor. This we add to the boom section manifold. Okay, so now we have the 4 major hardware components assembled for the DynamicFluid4. Now comes the clever software. This invisible component binds all the others together. The sprayer speed and status of the boom sections is monitored. We know exactly how much liquid the pump produces. We know exactly how much is going to the open nozzles. Let's show this in the field. If any changes occur to things that influence the application rate, the regulation valve will be repositioned so the application rate stays at the correct rate. The DF4 does this before the mistake is noted in the application rate. The flow meter and pressure sensor help in the fine-tuning of the valve position. Now you have seen how we make the Hardy DynamicFluid4. We hope you have enjoyed this episode, and we hope to see you next time, where we will cover the production of the Hardy tanks.